So hello and welcome back to Statistic 2, Linear Combination of Random Variables. And in this video, we'll be working on linear combination for one random variables only. So let's just say we have a random variable x. So x has the values of, just get random variables of, just say 1, 3, 5, 6, 8, 11, and 15. Right. Right, so these are just random variables. So let's find the mean of x. And the mean of x is actually here, it can be denoted by E of x, which is the expectation of x. So mean of x is basically the expectation of x, and this is equal to all these sum of all these variables at 1, 3, 5 plus 6 plus 8 plus 11 plus 15 over 7. So that equal to 49 over 7. So that's the expectation of x. So the mean of all these number is 49 over 7, which is equal to 7. So the expectation of x is 7. Now let's find the variance. So we have the mean, and now we want to find, the variance, and right, so let's find the variance. So the variance var of x. So we need to find first the sum of all the square. First we need to find the sum of all of these variables square. So we have, this is 1 square plus 3 square plus 5 square plus 6 square plus 11 square plus 15 square divided by 7 and minus the mean square, 7 square. So this is a formula that will be in the formula sheet. So I would recommend, if you have your formula sheet with you, to do these exercises. So the variance is equal to 19.7. Right, so that's the expectation of x, and this is the variance of x, so 19.7 and 7. So now let's just say we have another distribution. So we have a distribution called 2x. Let's just make it red. So let's just say we have a variable of 2x. So that would be, so let's say 1 times 2, so that's 2. 3 times 2, that's 6. 5 times 2, 10, 12, 16, 22, and 30. Right, so that 2x. These are right, so that's for 2x. So what is the expectation of x? So let's just say we want to find the expectation of 2x. Sorry, expectation 2x. So that would be 2 plus 6 plus 10 plus 12 plus 16 plus 22 plus 30 divided by 7. And that gets you 98 over 7. So it's 7. So that is 14. So the expectation of 2x is actually 2 times the expectation of x. So that's a properties of linear combination of random variables. So what about variance? So let's just say we want to find the variance of 2x. So this here is equal to 2 squared plus 6 squared plus 10 squared plus 12 squared plus 16 squared plus 22 squared plus 30 squared divided by 7. Now that minus the mean, which is 14 squared, and that gets us 78.9. Now, a funny thing about 78.9, it is actually approximately equal to 19.7 times 4. So 19.7 times 4 gets you 78.9. So for that, we have the basic formula of linear combination of random variables. Right, so now let's just say we have another variable y, and so we have the values of expectation of y and the variance of y. So this can use the same way that you find the expectation of x and also the variance of x. So now we're going to find for, say, 2y. So the expectation now of 2y is actually equal to the 2 times expectation of y. So that this has been proved from the last example. Now the variance, little bit different, is that the variance of 2y is actually 4 times the variance of y. 4 times, and 4 is actually equal to 2 squared. So similarly to this way of doing it, we can get ay with the expectation of ay. This will be equal to a times e of y. Now remember that a is a constant, right? It's a constant. So about the variance of ay is equal to a squared times var of y. Right, so that's the basic formula. Now what if we add a number? So let's just say we add a number c. So ay plus c. Now ay plus c. It still follow the same rule. So we have the expectation of ay plus c is equal to a times the expectation of y plus c. Now, because plus c is because all the values for y has a values of c added to them, and now that will also happen to the mean of y. So if all the values are added to an amount of c, then the mean is also added to the amount of c. So what about the variant? So the variant, however, is not affected by c. So this is equal to a squared var y. So variance is this. So it is not affected by c because c is a constant, and if we added it to ay, all the values are increased. So if all the values are increased, the difference between them does not change. So the difference stay the same, and so the variant actually stay the same. For that, we have these formula.